Previously, we've shown that if you have the limit as x approaches either a value of a or positive or negative infinity of the quotient of two functions, f of x and g of x, and that as x approaches a, these function values are approaching infinity, we can evaluate this limit by differentiating the numerator and the denominator. So we can say that this equals the limit as x goes to that a of f prime of x over g prime of x. But what happens if we have the numerator and or the denominator approaching negative infinity? Well, this is not that different. So we're going to start by looking at the limit as x approaches a of the quotient of two functions f and g. And we know that as x approaches a, f is approaching negative infinity, and that as x approaches a, g is approaching positive infinity. So we don't know how to deal with negative infinity over positive infinity. We only know how to deal with positive infinity over positive infinity. But this is not so bad. I can say that this limit equals the limit as x approaches a. I'm going to say, so we have the f of x over g of x. Well, it would be pretty nice if I had a negative right here, because as x approaches a, if f of x is approaching negative infinity, then negative f of x is approaching positive infinity. But of course, if I just put a negative sign right there, I change the whole thing. So that's no good. But what I'm going to do is put down another negative sign in the front. Because when you have like a constant multiple of -1, it doesn't matter whether it's inside the limit or outside the limit. So all in all, these two negatives will cancel out. But now on the inside, I have positive infinity over positive infinity. So I can do what we proved last time and differentiate the top and the bottom. So I can say that this is going to be equal to negative limit as x goes to a. Well, we have the derivative of negative f of x is just negative f prime of x. And on the bottom, the derivative of g of x is g prime of x. And again, it doesn't matter whether the negative is inside or outside of the limit. These negatives cancel out, and we can just say that this equals the limit as x approaches a of f prime of x over g prime of x. So we've shown that this equals this, which is what we wanted to show. And now for the next one, as x is approaching a, f is approaching positive infinity, and g is approaching negative infinity. We're basically going to do the same thing, but we'll have the negative in the denominator. So I'll say this equals the limit as x goes to a of f of x over g of x. This time, I'll put down a negative sign in the denominator, but then I'll also put down a negative sign in the front so I don't change anything. So now we have positive infinity over positive infinity. So we can just differentiate the top and the bottom. So we can say this is equal to the negative limit as x goes to a of f prime of x over negative g prime of x. And again, the negatives will cancel each other out. And we can say that this equals the limit as x goes to a of f prime of x over g prime of x. So we've shown that this equals this, which is what we wanted to prove. And now for our last case, we have that as x approaches a, both f and g are approaching negative infinity. So this time I'm going to look at this limit and say that this is equal to the limit as x goes to a of f of x over g of x. So this time we have negative infinity over negative infinity. So I'm just going to multiply the top and the bottom, if I can get this out of the way, by -1. So I'll put down a negative here and a negative here, and the two negatives don't change anything. So now I have positive infinity over positive infinity, so I can differentiate the top and the bottom. So I can say that this equals the limit as x approaches a. We'll have a negative f prime of x over negative g prime of x. And again, the negatives cancel out, and we can say that this is equal to the limit as x goes to a of f prime of x over g prime of x. So again, we've shown that this equals this, which is what we wanted to prove.